to start graphing, which I heard one or two teacher didn't get to it last year. So where your teacher might have done this like big time and you're like can fly ahead, maybe somebody in the same room has never seen this before. So I have to go through the whole thing. So the first thing I'm going to ask you to do is see this unit circle right here? Well, not right here, but this unit circle right here. I want you to go around this unit circle, good practice, and I want you to find the sine value at each of these angles. True. I want you to find the sine value at each of these angles before we do anything else. Okay? Find the sine values around that unit circle. Go. Try it.
Do you want the whole unit or just up to 9?
Huh?
The whole circle.
Not the whole.
For example, what is the sine of 0?
It's not go.
1/2. Oh, wait, that one.
Of 0?
That's what I want.
It's 0. What is the sine of pi over 6?
1/2.
That's 1/2. So take a moment, see how far you can get in the 30 seconds I've given you.
That's what I was going to do too.
Wait, I think I did it. Okay, I did do it right.
Let's see like this. You're writing the sine, you're not writing the So remember, there is a finger trick if you want to use this. The sine is the y value at each angle. It's the y value if you're looking at the ordered pair. And your hand trick gives you the ordered pair. So for example, at pi over 6, you put down the pi over 6 finger, and then the sine would be, this would become the comma, and then the sine would be radical 1 over 2, which is 1/2. And then at pi over 4, you put down the middle finger, and the sine would be these two, radical 2 over 2. And then at pi over 3, you put down this finger, the sine would be after the comma, it would be radical 3 over 2. It's always square root of the number of fingers up over 2. And then at 90 degrees, you put down this finger, it would be radical 4 over 2, which is 2 over 2, which is 1. Or use the ordered pair right here, which is 0, 1, to know the 90 degrees. Much easier. Okay, what I'm going to do is I'm going to color code what I'm looking at right now. I'm looking at the y value for each of these ordered pairs. I'm looking at the y value. So when we talk about y, we're talking about how high up it goes. So the sine at pi over 6 is 1/2. The sine at pi over 4 is radical 2 over 2. At pi over 3 is radical 3 over 2. And then when we get to pi over 2, the length of that is 1. That's the length of that pink line. Then as we go into the second quadrant, if I'm looking at just the lengths of the y values, how high up that point is, it looks like it's getting smaller and smaller and smaller until we get to 0 at pi. Those smaller amounts are the exact same amounts as it is reflected in the y-axis. Those are the exact same amounts. So radical 3 over 2, radical 2 over 2, 1 over 2. And so this makes kind of a mountain shape where we're getting bigger and bigger and bigger and bigger, smaller and smaller and smaller and smaller until we pass pi. Once we pass pi, what does my y value do at 7 pi over 6? It's getting bigger and bigger and bigger, but what's different about it now? It's going down, it's negative. So we've got negative a half, negative radical 2 over 2, negative radical 3 over 2, negative 1. And then once we pass 3 pi over 2, it's still negative, but it's less negative each time. So we're getting smaller and smaller, closer up till we get to 0 again. So negative radical 3 over 2, negative radical 2 over 2, negative a half, back up to 0. And circles don't stop. They continue on. They keep going around and around and around. So my pattern is going to be make a big mountain, come back down from the mountain, make a valley, all the way to the bottom, come back up from the valley. Then make a mountain again, come back down from the mountain, then make a valley again, then make a mountain again, then make a valley again, then make a mountain, and then a valley, and a mountain, and a valley, and a mountain, and a valley. It's always mountain and valley. Or if I go negatives, if I start at 0 and I go negative pi over 2. If I go this direction, I'm going to make a valley, then a mountain, then 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 a valley, then a mountain, and same thing over and over again, mountain and valley, valley and mountain, over and over again. Okay, so what I have here is just like an XY chart where you could do like negative pi over 2, 0, I'm just picking values, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi. There you go. I put some values. It doesn't fit everything because I didn't make the table big enough. This table here is just to show you how I'm taking this circle and I'm changing it into rectangular form. I'm taking the circle and my x values are now the angles, and then my y values are going to be whatever the sign is at that angle, which we just found, 0, negative 1, 0, half. I'm not going to fill all these out. This is just showing you, like, for understanding purposes, not just to get it done, but for you to understand how I can take a circle and change it into a rectangular graph. Okay? Because now that you're in pre-calc, it's not okay to just work ahead and get it done. It's okay, or what you need to do is understand it. Okay? I'm going to graph my points here, and then I'm going to put some vocabulary words on this front page that aren't there. But I can't graph all of these because some of them I don't know the answer to. For example, well, I know 0, 0, that one's easy. Oh no, I don't have anything on my y-axis. Let me say this is going to be 1, and this will be negative 1. Okay. Pi over 6 is a half. I can graph a half, but I don't have a pi over 6 here. So you're going to use your brain. If what you need to graph is not here, but it's somewhere, but it's not actually labeled for you, you figure out where it would be as exact as you can. Here's pi, and here's pi over 2. I do have those sign values. What's pi over 2? 1, and pi is 0. I do have those sign values. Pi over 6 would be easy to graph, and in this quadrant, right in the middle between 0 and pi, right in the middle is pi over 4. Right in the middle. So that means on this x-axis, in between 0 and pi over 2, right in the middle has to be pi over 4. They're going to be spaced the same. Is pi over 6 exactly in the middle of 0 and pi over 4? Is pi over 6, look at my circle, is pi over 6 exactly in the middle of 0 and pi over 4? Is it exactly in the middle? No. This is like 30 degrees, 45 degrees, 60 degrees, and then that's 90 up there. They're not right in the middle. They're closer to the 45. So when I draw my pi over 6 and my pi over 3 down there, they're going to be closer to that pi over 4. And it's an approximation. So at pi over 6, it's a half. That one's pretty easy to graph. But unless I pull out my calculator, which some of you told me you forgot today anyway, unless I pull out my calculator and find out the decimal for radical 2 over 2 or the decimal for radical 3 over 2, I can't really graph those because I don't know what they are. Pretty sure one of them's here. I've done it before where I pull out the decimals, but I'm not going to do that for timing purposes. I'm just going to go put the halves in there and put the whole numbers in there. So at 3 pi over 2, it's -1. And then I can put my half value at 7 pi over 6. And then at 2 pi, it's 0 again, and I can put my half value there at 11 pi over 6. This forms a very beautiful, relaxing curve. It goes from mountain to valley. Oh, you just graph it. It looks so nice and smooth. Isn't it relaxing? But remember, this graph is periodic. It's there's cycles. It goes over and over and over again, around. So it cycles back and around. I don't know what I'm trying to say. It doesn't stop. So we have an arrow. It doesn't stop the other direction, but I'm not going to put an arrow there because there's more graph that I need to fill out. So I have to follow the pattern, and I have to follow it and put the cycle in. So the pattern is mountain, valley, mountain, valley, mountain, valley, mountain, valley. So if I'm going to the left, I'm at a mountain here. Where am I going to go next? Valley. And I just look and see how far apart these are. Looks like my valley is going to be 2 blocks. And we go halfway up, 2 blocks. And I go all the way to a mountain, 2 blocks. And we go halfway up, 2 blocks. And this does not look like a zigzag. It is a nice, relaxing, beautiful wave. You're on the beach. A very desolate beach where there's no annoying kids running around. You just relax. Okay, ready? So this has a cycle. Here's one cycle right here. There's one time around the circle. That's one cycle. What that is called when we start talking about this is one period. The period is the horizontal length of one full cycle. So left to right, length, left to right from start to finish, how long is this period? It is 2 pi long. So the period repeats itself every cycle, happens over and over again. This length is 2 pi for now. What could I possibly do to this graph to make my period not 2 pi? Now if I took this, a vertical stretch, nope, a vertical stretch will not change the period. A vertical stretch would make it higher and lower, but it's not going to change the period. How could I stretch it that would make this period, which is horizontal, watch, horizontal shrink, horizontal stretch, do you see how it's getting longer or skinnier? That's what's going to change the period. Oh, we're talking about transformation still, huh? Yeah. Okay. Something else about this. There's something called a sinusoidal axis. sinusoidal axis. This is the midline. So this is an equation of the line that would pass through, excuse me, pass through the very middle of this graph. The sinusoidal axis. What equation is that yellow line I just drew? Y equals 0. What could change the sinusoidal axis? What could take this graph? What could take this graph? Well, a reflection, reflection is still going to have the same midline. A translation where? Up or down. A translate up or translation down is the only thing that will change that midline. So that will be affected by, I should probably write what these are affected by. Is it effect or affect? Is it affect? Affected by? Or effective? Affect? Changed by, I think it's but okay, changed by, so the period is changed by the horizontal stretch or shrink. Sinusoidal axis would be changed by a vertical translation, which is up or down. We have another vocab word, and that is called amplitude. The amplitude is how far above and how far below the peaks and the valleys are from that midline. How far above and how far below this graph goes from the midline. So what is the amplitude for this particular y equals sine x graph? How many units does it go above, or how many units does it go below? It goes 1 unit. You will not say -1 because some of them are up and some of them are down, so we use just that as length. It's 1 unit long. And what do you think could affect how high up or how far down this graph would go? Vertical stretch or shrink. So changed by So the 3 vocab words I just went over here, they are for all of the graphs that we're doing, not just sine, but I'm not going to rewrite it for cosine. Cosine is going to be a lot like sine. I'm not going to rewrite all this stuff, so we have it once. We don't need to go rewrite it again. So cosine is on the back. We start and we look at the unit circle. And sine was the y values. What's the cosine on the unit circle? It's the x values. So we're going to go around our unit circle and we're going to look at the x values. And I'm just going to look at these right now. I'm going to go from from the origin, I'm going to go to 0. And that is the length of how long? What's the cosine of 0? I just made it pink. How long is it? 1. At pi over 6, we have a length. At pi over 4, we have a length. At pi over 3, we have a length. And at pi over 2, I don't have any length. What is it at pi over 2? 0. Now, just filling these in, at pi over 6, if you're using your hand thing, this is the comma. At pi over 6, it's going to be the x value, so it'll be the first 3 fingers. So that'll be radical 3 over 2. At pi over 4 is radical 2 over 2. And at pi over 3 is 1 over 2. And then what happens when we go into the second quadrant for cosine? It becomes negative. So we're going to go negative, more negative, even more negative, very negative to negative 1. And from there will be less negative, less negative, less negative, down to 0. And so I can fill those in really fast. Excuse me. And then after we go from 1 all the way down to 0, then we go negative, negative, negative to negative 1. We come back up to 0. We haven't finished cosine yet. We now have to go back positive. 1/2, radical 2 over 2, radical 3 over 2, back to 1. Then we go back down again. Then we come back up again. Then we go to a valley. Then we go to a mountain. Then we go to a valley. Then we go to a mountain. And then a valley. And then a mountain. And then a valley. Mountain, valley, mountain. It sounds familiar, like I just did that on the first page. The only difference between these two is where you're starting. So when we go and we graph these and we start at 0 on the x-axis, my cosine value is 1. Where when I started sine, it was 0, 0. This one now is 0, 1. So we're starting in a different place. And then we're going to follow our pattern. And at pi over 2 is 0. At pi, oops, I didn't mean to make that a dot. At pi is negative 1. At 3 pi over 2 is 0. At 2 pi is 1. The original cosine graph we are doing it today. Yep. That's why we did that extra chapter at the beginning instead of starting right with, well, that's one reason why. Rather than starting right with trigonometry, we made sure to go over graphing because now the stuff that we did in the first chapter applies to this chapter too. All those transformations. When you do graph cosine, here's a pet peeve of mine. At the end of it, where would I go next? I ran out of graphs, so I can't. But where would I go next? I would go back down. So when I go to draw my arrow, I'm not going to draw my arrow going up. I'm going to like curve it around and show, I know that it's going to go down next. I just ran out of space. Okay. And then up here at 1, 0, when I go to do the other direction, this is a top of a mountain. So I'm going to go middle of the way, valley, middle of the way, mountain. Like I have to still have mountain, valley, mountain, valley. I still have to have that same pattern. And because we are doing transformations and because sine and cosine look so much alike, if this is the only picture I gave you, you could not tell me if this was sine or cosine. If you didn't know the equation and I just gave you a picture, you could not tell me what this is. Because sine and cosine look exactly the same, and once we start putting in transformations, it could be either. Okay? All right, there is a super fast that I'm not going to read. Located and what they do. And then there's some notes here that really use these notes. I like to do it kind of my own way. I kind of use these notes. But anyway, I'm going to read this stuff to you, but not read it to you. I'm just going to like do it. And there's no way in class time today we have time to do all of these questions. So we're just going to skip ahead. We spent a lot of time on transformations already. You guys have done it for years. We're just transformations. Okay? Let's go all the way to number... Let's go to number 4, and it printed bad. It printed bad. I know it printed bad. So what I'm going to do is I'm going to skip number 3. And I'm going to use the table 4. I'm going to use the table 3 for number 4 because it printed bad. I don't know what happened. But it had already printed, and that was a lot of paper, so I wasn't going to reprint them. All right. First thing that you want to do is just figure out, is it cosine or sine? Cosine. Then we have to fill in our values, and I will not always give you x values. I'm giving you them now because it's day 1. Eventually, you won't be given x values. But you're not given y values. You've got to figure this out. So what we're going to do is we're going to think about, when I graph cosine, the easiest points to graph would be the extreme high point, the extreme low point, and the middle points. So when you look around the circle at 1, 0, 0, 1, negative 1, 0, and 0, negative 1, those are the extreme values. Everything in between is in between 1 and 0. Everything from here. I don't know what I'm saying. These are like the highest and the lowest values. So when I go to find cosine at 0, I'm looking at the x value, which is 1. Then I go to pi over 2, 0. Pi is negative 1. 3 pi over 2 is 0. 2 pi is 1. That is one full cycle. From there, you would just repeat, repeat, repeat. Follow a pattern. So we're going to do one full cycle around the circle here. And these are our parent function points. You do not need to graph the parent function and the translated function. Let's write out our transformations. So if I have a negative, a 4, and a plus 2. Let's start in order. What's the negative? Tell me. Kia. What kind of reflection is that? In the x-axis? Reflect in the x-axis. So if you're not sure which one that is, we're talking about, here's our x-axis, and we're going to reflect up and down in the x-axis. Is that vertical or is that horizontal? Where's my finger going? Vertical or horizontal? That's vertical. So in our table, we will go to the vertical side, which is the y side, and we will multiply by negative 1. I probably shouldn't have filled that out yet. Because what's next? What's the 4? Vertical stretch. Factor of 4. So that means I'll go to my vertical side and multiply by 4. Well, I'm not going to multiply by negative 1 and multiply by 4. I'll just do them at the same time. So multiply by negative 4. And then what's my plus 2? That's a translate because it's adding. But is it up, down, left, right? Here's the tricky part. Here's the tricky part. If there's no parentheses, the addition has to be vertical. I will show you what it would look like here. I'll show it to you with this one since we're not doing this one. If it were horizontal translation, it would have to have parentheses, or it would not. It won't be horizontal unless it has parentheses, okay? So when you look at this and there's no parentheses, you know it is vertical. So if there's no parentheses, it's vertical. What direction am I going, Zoe? Up. 2 units. All right, so now I'm going to fill out my table with a plus 2 on the y side also. What do we do first? Multiply or add, or does it matter in math? It does matter. PEMDAS, right? So I knew what I was doing when I filled this out. I knew I had to put the multiplication first. Okay, so we'll multiply and we'll get negative 4, 0, 4, 0, negative 4. Then I don't use those ones anymore. I add the 2 to my previous column. So negative 2, 2, 6, 2, negative 2. And now I don't use the column with the 4s anymore. I have my x's and my y's to graph. 0, -2. Pi over 2 is 2. Pi is 6. I did something wrong. Oh, I didn't put it at 2. There we go. 3 pi over 2 is 2, and 2 pi is -2. Does this look like that cosine graph that we graphed as our parent function, kind of, with transformations on it? Has a reflection, so it's upside down. Has a stretch, so it's longer. Has a translation, so it's moved up. But it does have that kind of cosine look that's like two mountains in a valley. Just upside down. So now we have to find the information. I'm going to find things like the sinusoidal axis, which is that midline. Oh, lunch. How do I always forget? Have a good lunch. We'll finish this right after lunch. Okay, so I believe right before lunch we were talking about this big yellow sinusoidal axis. We have to write the equation of it. That sinusoidal axis by any vertical translations, which we did have a vertical translate up to. So instead of at 0, it is now at y equals 2. The amplitude is how high above and how high below the sinusoidal axis. It is affected, the amplitude is affected by any vertical stretch or shrink, which we did have a vertical stretch of 4. So how high above and how high below does this graph go from the midline? 4. Now the period is the horizontal stretch from start to finish, not stretch, horizontal length from start to finish. It is affected by the horizontal stretch or shrink. Did we have a horizontal stretch or shrink? We did not. So how long is the period? 2 pi, like, didn't change, so it's what it normally is with the parent function. Okay, I have to finish, I don't know why I didn't finish drawing this yet. I have to finish graphing my points, so we're just going to follow the pattern where if it's a valley, the next thing will be a mountain. If it's a valley, the next thing will be a mountain. Then a valley, then a mountain, then a valley, and then a mountain. You're going to be asked to write your domain and range, and we're going to put those in interval notation. So from left to right, does this graph ever stop? Does not stop, doesn't skip over anything. Left to right, it goes from negative infinity to positive infinity. The range is how far down to how far up, how far down to how far up, and it definitely will start at something and stop at something because it's only in between these 2 points here. So the lowest number is -2 and the highest number is 6. So it can include those. You're going to put -2 with a bracket and 6 with a bracket. Okay? As you're working on this, I'm going to come around when you work on the next one. I'm going to come around and just kind of want to peek over your shoulder and make sure it looks right to me, because some of you, I might be going really fast and you might have missed something. So what I want you to do now is I want you to start number 5. And the first thing you want to do is think about the y value being the sine of x. And you want to figure out for those angles around the circle, what are the sine values? What are the y values for each of these ordered pairs? And then then you need to write down your transformations. Sorry, I'm peeking at what you had before, and it's like, it's on the other page. Oh, that looks like a zigzag. Hey guys, you want to see an example of a zigzag? Don't make it a zigzag. Zigzag bad. Nobody. Here you go, Ethan, here's your paperback. Alright, take your grass. Ah, you didn't even finish.
Oh, whoa.
And it's a zigzag.
I tried to curve. I tried to curve it right here.
It's going to be fatter than you think. It's going to be just fatter.
Oh.
But I was saying.
Oh,
That is the straight line. But that looks wrong.
quit. Let me see it.
I got a whole pass over there. This is cosine.
So, and this might have been something that Madison asked me when you guys went to lunch. Kind of the same thing that you did also. This is a cosine of x, and the cosine around the circle are the x values. Even though it says W, we're still writing the x values.
Okay, what about that? Where's partial unit?
You did not get very far enough.
Oh, I just.
No, but it might, I mean, probably should, but not right this second. Go ahead and work ahead. I'm just coming around to see things like zigzags, or if there's something you didn't understand, like, this would not be okay for a test. That's it. I know you. Almost zigzaggy on that side. Almost. We wanted to do it bad. That is a zigzag. Could you see how it looks? Let me see something.
That's right.
Fatter.
What was that? I couldn't say that. Oh, I heard that.
That's zero. Like, it comes to a point. I really want to try to remember this. Yeah, I'm going to do that. Just a moment. Just want to walk around and see everybody's graphs before I went on.
Please do.
Kind of zigzaggy. Nah, it's kind of zigzaggy. Like it's too close at the top where it needs to be very much. Okay, I'm going to do this now, so questions possibly will be answered. I just wanted you to write the transformations, and if you could go further, great. So this 3 is going to be a vertical, what? Stretch, factor of 3. And then the 1/2 is horizontal because it comes after the x. Normally, if there's not a horizontal translation, you don't have to have parentheses. If there were parentheses, it would be here. But you don't have to have it if there's not the translation. So 1/2, that's going to be a horizontal stretch. Factor of 2. Because remember, we have to reciprocate it when you go to multiply for a horizontal. And then the +1 will be translate. Combining. Translate up 1 unit. So in my table, anything vertical is going to go, oh, I didn't do my sign values yet. My sign values start at 0, 1, 0, -1, 0. Anything vertical is going to be y side, so I'm going to multiply by 3, and then I'm going to add 1. On my x side, I'm going to multiply by 2. So I'll do my y side first. I'm going to multiply everything by 3. And then from that number, now I'm going to add 1. So I get 1, 4, 1, negative 2, 1. On my x side, I'm going to multiply each of these by 2. So I get 0, and then when I take pi and I multiply by 2, right now it's not too hard. But in the next section, what we do tomorrow might be a little bit more difficult because you have to be able to multiply fractions. You might have to add fractions in our next section, not so much in this section. When I multiply these, I go straight across and I get 2 pi over 2, which is pi. And I take pi times 2 is 2 pi. I take 3 pi over 2 times 2, and I get 3 pi. And one nice thing is that the x will always be evenly spaced. So if I see my pattern, 0, pi, 2 pi, 3 pi, 4 pi, they'll always be evenly spaced. So I can get rid of those old x's, and I'm graphing the new x's and the new y's. I'm graphing 0, 1, pi 4, 2 pi 1, 3 pi negative 2, and then I go to graph 4 pi, but that's off the paper. So I'm not going to just sneak it in here and make my graph look all bad. I'm just going to not graph it. So I'm going to graph as much as I can fit, and this does look like a sine graph. It's got the mountain into the valley, and it would come back up to the midline, but I ran out of graph. I need to connect that with a pattern. I'm looking how far apart all the points are. It's like 2 points to my next dot, and this is a mountain, so my next one is going to go to valley. And then I'll be halfway, and then we'll go to a mountain. Oh, I didn't go up high enough. Somebody forget to put their phone up? Oh, really? It sounded like it was over there to me. I'll go by you guys. My ears are like not good. Okay, so I have a graph. We're going to fill out our information. The period is affected by the horizontal stretch or shrink. Here is my little piece of paper. If I have a sine graph and I have a horizontal stretch or shrink, that's going to change how long horizontally this one cycle stretches. Okay? Could be shorter, could be longer. So we do have a stretch or a shrink. We have a stretch, factor of 2. So where the period is normally 2 pi, we have a horizontal stretch of 2. I'm going to do that to the period. And I'm going to have what for my new period? 2 pi times 2. Don't whisper it. Say it out loud. 4 pi. What if you're... Oh, no. What will we do?
You say no, and then on the inside, I'm hurting. It's like, no, we're just
You guys need to get over that. Not everything in life is going to be a yes. Okay. I'm just helping you grow up a little bit.
No.
So the period, you take 2 pi and you multiply by whatever you multiplied your x's by, and that's your new period. The amplitude we talked about earlier is affected by a vertical stretch or shrink, which we had. So the amplitude goes from the sinusoidal axis, which is the midline, which we didn't write down yet, and it's how high above and how high below, or what's the length below. For this one is 3. It is the vertical stretch or shrink. It is the same number. The sinusoidal axis is affected by any translate up or down, which we had to translate up. So where it's normally y equals 0, we went up. This is now y equals 1. Domain left to right, this is all real numbers. So negative infinity to positive infinity. Range is how far down to how far up. It goes from negative 2 to positive 4. It's like right in this little area right here. With the last one, I'm not going to do all of the last one. I just want to show you that you can find some of this information without even graphing or filling out a table. You can actually find some of this information. The period. What changes the period? What changes the period? Do you know? Do we have a horizontal stretch or shrink on this? We do. What would we multiply by? A half. So I'm going to take my period and multiply by a half. I'm going to take my 2 pi and multiply that by a half. And we get pi. That is the period of this graph once I would graph it. The amplitude. How do we get the amplitude? Hallie, do you know the amplitude?
The horizontal.
Horizontal is the period. Amplitude is up and down.
Vertical.
Vertical what? Stretch or shrink. Do we have a vertical stretch or a shrink?
No.
This is not a stretch or shrink. That is a reflection, so no. So that means we don't have a stretch or shrink. It's whatever the parent is. How high up and how, or what number is here besides the negative? 1. It's 1. Sinusoidal axis is affected by what? Alex, what changes the sinusoidal axis? Okay, so this says -2. So where's my sinusoidal axis going to be at? Perfect. See how I didn't even need the graphs because these go off of transformations. If you know your transformations, you can do that information. We did not do one transformation today, and you won't have it in your homework today. Do you know which it is? We did vertical translation. We did vertical and horizontal stretch. We did reflection. What did we not do? Nope. Stretch or shrink, I'm counting as the same thing. We actually did a horizontal shrink here, and we did a horizontal stretch here. Huh?
Horizontal translation.
Horizontal translation is the correct answer. I don't know what people were saying, but we did not do a left or right translation. That's for tomorrow. So if you turn your page, you'll notice that this is day 2 notes. And then in the homework packet, I'm going to give you a packet. In the homework packet, there's 3 separate assignments stapled together. So you only have to do the first assignment for your homework. Okay?